Hello everybody and welcome to this next online session from Barcelona Jack. As usually, we're going to start with our presentation, which is yeah, we've got a problem now with the presentation because well, it doesn't matter. So we are the Barcelona Jack, a non-profit, cooperative, which we try to create as many events as possible, talking about Java, but not only Java, but also some kind of other technologies involved in Java, like NoSQL databases or languages based on JVM, like Scala, Ruby. And well, we always trying to improve our presentations and having better speakers. So our main focus is that the developers from Barcelona and around the world can improve their skills. So today we're going to talk about Arquillian. We've got Aslak Knutsen, which is the leader of the project, and remember that the next session we will have, it's about Forge, JBoss Forge, which will have Ivan from Bulgaria, which is an awesome guy, and it's a contributor of Forge. So I'm not going to talk anymore, and please, Aslak, start and show us what we can do with Arquillian.
All right, thank you, Alex. So I'm gonna just jump into a bit of a short presentation to just go through some of the basics, and then we'll look at some examples afterwards. Let me just share the screen here. And right, so before we jump into what Arquillian is and how the Arquillian universe works, the universe has a couple of rules, basically. We can say the first one is that a test should be portable across multiple supported runtimes, supported containers in this case. But container is a very wide term and doesn't necessarily restrict us in any form or fashion. It's something that can be started and stopped. And two, a test should be just as well executable from the IDE as from the build tool. So you shouldn't have to swap out of your flow when you're working in the IDE to then run over to the build tool and the command line and run a bunch of commands, and hopefully half an hour after it will eventually have seen whether or not the test failed or not. So Arquillian should then run from the IDE, from the same flow that you're in, and be able to give you a much quicker response. Is the general idea. And then as a platform, it should extend and integrate with the existing testing frameworks that are out there. There's a lot of tools that work splendidly on their own, but when you start to join them into containers and you need to run them in containers, you have the problems that there's no coherent solution to kind of join them all together, and that's where the Arquillian testing platform kind of comes in. So let's just quickly go through the basics of what Arquillian is and how it's structured. In the bottom, you have the Arquillian core, which is a tiny event machine that doesn't know anything. It doesn't do anything useful per se. It knows how to receive events and to fire those to potential observers. We'll see it as a testing platform or middleware for your tests. basically it's not a test framework in itself. It relies on other frameworks to run it. But it handles a lot of the plumbing for you, basically. It allows you to move across different containers and move across the different environments and integrate all of these different tools for you. It's built modular and extensible and flexible to be able to handle anything from tiny bean container to a multi-server environment, and from CDI to EGB to Spring to any of the different normal programming models that you have in the Java space. And it's extensible in the sense that it opens up pretty much everywhere for the user or for other extension developers to write new functionality and plug it into the core by observing these different events and so on. And that makes it extremely flexible as well. So when looking at what builds up what we could consider Arquillian core, on one side it's the test extension. That's the SPI for test runners, a way for the different test frameworks to integrate with the Arquillian core and to push its events onto the Arquillian core bus, basically. It will fire off events like typical the lifecycle events which you have in JUnit, like the before suite, before class, before test, and after class, and after suite. On its own, this extension provides a means to be an abstract layer between all the different testing frameworks. So there's support for JUnit, TestNG, Spock, JBehave, Cucumber, and 2CDs that all run Arquillian. It's not Arquillian that run them, so they're controlling the lifecycle of Arquillian. If you were to just use this extension on top of Arquillian core, what you will end up with would be a way to extend the functionality of any of these test frameworks in one go without having to know the internals of how JUnit or TestNG and the different ones work. On the other side, there's the container extension. Similar to the test extension, this provides SPIs for interacting with some form of container. As I was saying, that's a very loose term, so it's anything that can be started or stopped and potentially be deployed or undeployed to or from. On top of that, it adds events like before deploy or after deploy, or start container and stop container, different types of extension points, basically, where other extensions can interact with or can call upon. Some of the container adapters or implementations, like we saw on the test runner side, are pretty much all of the different Java EE app servers, but also things like bean containers like Spring and Weld or OSGI, or even have the Android phone or the iPhone as a deployable container in this fashion. And if you were just to use the container extension with the on top of Arquillian core, you basically have the lifecycle control over a container, so you can start and stop and deploy to it. And then there's the container test extension, which binds those two extensions together, basically listening for the test events on one side and forwarding those to container events on the other side. So, for instance, when before class happens, it will do a deployment. On before suite, it will do a starting up the container. It's an example. So let's look at the basic test class, what that would look like. This would be a fairly typical JUnit test case where you have some kind of a class that you want to test. You have your test method, and you create some new instance and assert some form of state. When you add Arquillian to that, we're reusing the JUnit extension point run with, where JUnit is handing over the execution control to the Arquillian runner, and Arquillian will then go through and find, for instance, the deployment method. That's a way to describe the intended environment that this test case should run in. It's your isolated environment. And then in this case, we're using some form of injectable bean, so we're reusing the specifications and can inject the live instance of that bean back into our test class. And then from a test method point of view, again, we just assert on whatever state we need to assert on, like we would do in a normal JUnit case. So let's quickly just see something run. And we were talking about this running from JUnit. So we're just going to do, we're going to have this one open, and we do run with JUnit test. We have an application server here in the background up and running. You can see deploy will start up some stuff, and voila, we have a green bar. So what's actually going on in the background here? How does this whole thing work? First off, we need some form of setup. It's not required to use dependency management system, but it's highly recommended just because dependencies are easier to manage when you have a dependency management system, surprisingly enough. So in the Maven example, you will define the Arquillian BOM, which defines some of the versions of the different subsystems here, for instance, shrink wrap and shrink wrap resolver. And then you depend on the test integration that you want. In this case, we're going to use the JUnit integration. And as we see in the test case, there's nothing here that's defining which container this is supposed to run in. The only thing the test case in itself defines is what type of archive, for instance, it needs. We need something that's going to support a web archive, and presumably something that can inject our bean. So let's say it's going to be CDI. And in this case, this class or this test itself could run on either a full application server, or it could run in the bean container. In theory, also the spring container, depending on what kind of bean this is. So how do we define that's gonna, or where it's actually gonna run? The first step is then to select some form of container. So we use that by scanning the dependency tree again. So we're going to add here the remote adapter for the JBoss AS server. It could have been WebSphere, it could have been Glassfish or Wi-Fi or whatever we wanted to. And when then Arquillian starts up, it's going to start or connect to that container, depending a bit on what kind of container adapter it is. It could be starting a local server up as part of the test suite, or it could connect to a remote container somewhere in the world, basically, either on your local machine or in your test environment, or somewhere in the cloud if you wanted to. Then Arquillian comes into what we consider the packaging phase, which is where the deployment method that you saw earlier came in. That method is being executed, and what's being returned there is what's being deployed to the server. And the framework we use to handle the deployment is a project called Shrinkwrap. Shrinkwrap has three different shapes. So one is the pure archiving library, where you could either create Java archive, web archives, enterprise archive, resource adapters, OSI bundles, whatever type of archive you want. Essentially just a Java API around a zip file, or potentially a zip file. So this is where you add your classes, your packages, your libraries, your modules, your web XMLs, and whatever else you want to define this testable unit, or what this testable, or this test class and the thing you have on the test actually needs. And if you need to resolve other dependencies, not just classes from your local class path, but libraries from the Maven repositories, for instance, you can easily use the shrink-wrap resolver, which is a Maven resolver or a Gradle resolver that will resolve from the remote repositories and pull in potentially with all the transitive dependencies, etc., for a given library. And then there's the shrink-wrap descriptors, which creates a fluent API on top of the content of some file. For instance, web XML, application XML, HTTP, jar XML, and all those type of descriptor files. So you can easily create and wrap up a whole bunch of different configurations easily without having to go through the file system and have 20 different variations of a web XML if you're testing specific authentication mappings or whatever you might end up testing. And somewhere along the line here, Arquillian might also include itself to be able to run in the container. And then it will actually deploy that archive that has gone through the packaging phase and move on. The fourth step then is to move the execution of the test from the client side over into the container. And when the test is in the container, it has access to all the resources that the container itself provides, that being JNDI resources, database or data sources, GMS, queues, security, and all of those kind of things, and can inject and use those resources as if it was the application itself that we're using them. And then, of course, it has to capture the results and return the results of the executed test back to the client side and through the test extension and up to the test framework. So as far as the test framework is concerned, everything looks the same, and it doesn't really know that this test was potentially forwarded to X number of other servers and the result were returned. So the result will look the same when you run it through the IDE, or it will come out through the Maven Surefire reports, etc., etc. So the whole tool chain going after an execution of an Arquillian test will behave the same as any other unit test. And then it will, of course, undeploy and clean up after itself. So Arquillian has a few different run modes. The default one and the kind of special one is the in-container version, where, as I said, the test actually has access to the internals and can use all the resources that are available there. The other one is as a client, where the test the test execution isn't actually forwarded into the container, but is running in your IDE or in the Maven process. And you can sit and poke on the external endpoints like the JXRS services, WebSockets, remote DJBs, or whatever you want to expose in your app server. At that point, Arquillian doesn't actually bundle up anything special with the deployment. It just takes the deployment that you've given it and deploys it directly. And then there's a mixed mode through the Arquillian Warp extension, where you can, during a HTTP request, assert or activate events on the client during that request. So, for instance, you can attach yourself to code that's going to be executed before a servlet is executed, or in some specific JSF lifecycle, for instance. So with that, that should cover the basics. Let's go over to some more demos. So we're just going to go through some of the extensions and just start off with core first. So we do the REST execution. It's just simple and easy to do, and it's one of the tests that actually used the client run mode, so we're not actually executing inside the container at this point. As you can see here again, maybe I should up the font here a little bit. Forgetting that. So we're saying to JUnit, use Arquillian as our deployment. Don't make it testable, meaning don't make it an in-container test. Deploy whatever we have defined here, which is a simple. It has a REST endpoint. It creates some JPA stuff, the backend, which is pretty standard HTTP3 stateless session bean that operates an entity manager and can store our objects and so on. Fairly straightforward stuff. Then exposed again through a REST endpoint. Much as basic as you can get it in this variant. So, as far as the test goes, we're just saying call this given URL and make a post request and just assert that we get the correct response code. This is a demo, so it's not doing very much useful. And since Arquillian is the one that has control over the container and the deployment, it also has more information about where and what was deployed. So we have an option to, for instance, inject back the Arquillian resource, which is of type URL, which is the URL or the base URL to where this web archive was deployed. So basically, localhost 8080 / whatever name it has, and so on. Allows us to basically abstract out the, instead of having multiple different properties file, for instance, for the different servers moving from your local development machine to the local or to the testing environment at the office or staging environment and so on. You can just rely on Arquillian to inject that URL for you. And again, this is just run as JUnit. We'll see it do some deployment. It will actually do some execution. We should see, in this case, Hibernate doing some insertions. We're selecting it again. And as far as the test is concerned, we got a green bar. So that's a very simplified REST version. Let's see, for a simplified in-container version, again, the same stuff. In this case, it's a EGB jar we're injecting. Sorry, we're testing. So we can deploy a job archive instead of a web archive. And this is going to be an in-container test, so we actually have the option of injecting things like our EGB, the conference repository, or since we're in the container, we can fetch the user transaction and control when the transaction starts and stops and when we commit and roll back. As far as the test is concerned, we just want to make sure that we can store a conference in one transaction, commit it, and get it in a different transaction to make sure that our transaction handling of the repository actually works the whole way down and up again. And all this stuff at the bottom is just some simple helpers to basically do the callables within a transaction. And then we're just making sure that what we try to store is the same that what came out of the database again. We can do a breakpoint here and connect the remote debugging to the server. to the server and verify that we actually are in the container when we run this. Since this is a remote container, we don't have to run necessarily the client side in debug modes, but the server is connected to a debugger, so we should still see the breakpoint kick in. And there we go. And here you can see we have the repository. That's a EJB proxy for our conference repository. We have the transaction, which is a well proxy coming through, which is the CDI proxying. You can see on the stack trace that we're actually coming in through, in this case, Wildfly's servlet engine, as opposed to being on the inside the local Eclipse JUnit runner. And now we have the option, of course, to step through all of this as much as we want and have the same feel as a native JUnit test, rather. See, what we got back is the same. We're happy with that. Now that's what core offers in itself. So that's the in container and the as client run modes. So let's look at the first extension, which will be, since we're doing JPA stuff here or database related stuff, let's look at the Arquillian persistence extension. That allows you to simplify some of this stuff. You don't necessarily have to assert on individual fields like this. This is all just test. The only thing that's really relevant here is the store and the get. Everything else is basically test CRUD. So the persistent extension tries to remove some of that. So here we have split up the same test case essentially in two different steps. So we're still deploying our Java archive, we're still injecting our conference repository, but we're letting the persistent extension handle inserting the data and matching the data for us, and also cleaning up the data in the database. The only thing we care about is creating our model and storing it, or potentially getting it from that repository. So how does this stuff work? Well, persistent extension comes with a couple of entry points and uses, by the way, the DBUnit extension in the bottom, plus a couple of other mixes to load the different data sets and so on. So it will look and package up for you excuse me, a conference with speakers YAML file, which is this file. That's where you describe the database contents, basically. So we have a conference table with one row which has an ID and a location and so on, and a user with an ID and a name. And then that user belongs to a conference somehow, or in this case, it's actually a speaker at that conference. So before this test is executed, the persistent extension will then insert this data so we can get it here and verify that our repository can actually read from the underlying data source. Or in this case, we're storing a conference. It will, after this test method, it will match that the different tables defined in this YAML file actually match what is in the database now, except for all the IDs, because those could potentially be auto-generated, etc. And again, of course, this is nothing more fancy schmancy than running it with run as JUnit. there we go. Should see complaining about different stuff, and then creating the data set, inserting the data, selecting that, and so on, and verifying that it actually happened. So then we have what? We have the in container and database. So let's look at, we can go through the test that we saw in the demo earlier. So this is the drone extension, which is an extension to handle Selenium or WebDriver type of interactions. And essentially support all the WebDriver drivers that are from the Selenium project, either being Internet Explorer, Firefox, Chrome, Safari, the Android driver, and so on. So the only thing that's new in this case is that we're actually injecting, using the drone annotation, the given WebDriver that we want to use. Now, all the configuration, etc., has been extracted out into different files. So that's in the Arquillian XML file, where you can see we're saying we want to use Firefox. That's basically the only thing you need to define, unless you have very specific needs. And then we go on using the WebDriver as any other, or in Arquillian as we would in any other WebDriver scenario, fetching the different IDs and so on from the result of our JSF page in this case, and inserting the data and then sending the data to the server. We can try to debug this as well, just to see what's happening. Now I started it, and we should see a Firefox pop up. And go to through. You can see that it's actually inserting the different stuff and clicking save, and we're happy with the current state, and the browser will shut down again. Now, Selenium is known for being a fairly verbose way of dealing with all these IDs and all the special CSS classes and so on, especially if you do it in this fashion. And that's where we have something called graphene that comes into play. But actually, before we go to that, let's go through warp. Warp is the one that that mixes both of them. This should actually not be a position. That mixes both the different run modes. So again, we're doing similarly, just doing the drone injection here, getting a WebDriver, but then it comes something fancy down here. So we're saying when we actually click the save button during that call to the server, we want to inspect it, sending over this specific object. The object takes our conference object in, it injects the conference repository, and in the after servlet phase of the request or the store, we can actually get the conference from the database and verify that it was actually stored within the database and not just our web UI returning something without it, basically without storing it anywhere. So this is a good place to do some breakpoints again. So we can run it first to see that it actually runs through. Just see a driver pop up again, as we did. And a green bar. So now we can actually do a server and client side debugging. We're still connected to the server side, and we're gonna run this test in debug mode as well. Debug as JUnit test. So at this point, we're on the client side. We can see us coming in from the remote test runner in Eclipse. We can step through the different stages, basically insert a form, and then we're going to get into this place. It says when we're going to submit it, then we're going to do the verify conference step. Now, all of a sudden, we're over on the server side, coming in through here, this servlet in Wildfly, and we have injected the conference repository and has the option to assert that that was actually dumped to the database or stored in the database properly. So then you have kind of both worlds in one. And we all know that this type of Selenium stuff is not very nice to write at all. So what you can do with an extension called Graphene is to extract that away. You can extract that away into what Selenium refers to as page objects, and Graphene has the notion of page components. So they're reusable pages that encapsulate the behavior of the application and how to interact with or how to find the different elements in the response, and then it's components that are reusable components. For instance, your login button or similar, that's going to be happening on multiple different pages. Or if you're a developer of a UI framework, for instance, like rich faces or prime faces or Badin, they have their own components, which they can then wrap up in the Graphene components and provide you with an API of a Java API rather of how to interact with their rich server-side component, but make them rich client-side test components as well. So instead of having to try to locate where the ID of div number 400 and figure out that that's actually the link for the next page, etc., they can provide you with an API that basically says get next page in the Java model. So how's that done? Well, first off, we're also using a different feature, which is the initialized page, saying that the conference page has a specific location within the application that we're deploying. So Arquillian and Graphene together knows that this is actually supposed to be something like this, depending on where you're actually deploying it. Or it could be my cloud, whatever. And then when you inject it into a test method, it will automatically move the browser to that point. And then the conference page is the conference page has a form inside it. So there is some div or some element with the ID of create, which is then internally can inject a reference again and wrap that around into a new object, which has a root, which will be the element that's create, and then other sub-elements. And you can then simply create a Java API on top and say send message, send key, send location, and then do the submits. And the Java or the test code becomes much more maintainable. It's easier to see what's going on. It's easier to change, and there's multiple ways of how to layer this different interactions on top of each other and actually get a Selenium API that's more maintainable than just having stacks and stacks and stacks of these type of expressions in the Besides that, yeah, it's using also warp. So when we submit the form, we're going to verify that it's actually being ran on the that it's actually being inserted on the container. From a test perspective, this is basically exactly the same, but we can still run it just for the fun of it. See something happening. Go and starting up the browser, entering, and green bar. Awesome. So that was the basics of some of the extensions. So let's see. Can show you a more advanced example doing some REST testing, for instance, from the continuous enterprise, the continuous enterprise development in Java book. So we have REST conference. So here we have a test case. It goes through a whole section of the REST API and uses the linking of the REST API to actually discover itself going forward. So it's using a feature in the JUnit integration that is the annotation in sequence. So basically allowing Arquillian to sort the different test methods in a specific order. And by that, since the test class also have a state, or at least a statically state on the client side, you can, for instance, go to the root of the REST API, figure out what's the link to the next location you want to, and then create a specific. Well, okay, let's actually explain the whole thing here instead. So we're going to go find the conference link that is defined in the root of our REST API. Then we're going to create a conference by posting to that URL. That REST service will, of course, return the URI to the actual conference instance. So the next step we want to do, we want to see that we can actually fetch that and see that it has certain links on it, and yeah, that the conference has been created in a way we wanted it to. And then we want to try to we want to update the conference based on the same conference instance ID that was found previously. Then we want to verify that it's been updated. Then we want to add a session to it, and then we have a new URI to find, which is a session instance. So we want to do the same to a session instance. So we have a conference that has multiple sessions in this case, and then just basically go through and verify the different steps of the REST API in a completely dynamic manner without knowing too much about the specific URLs, and rely on the linking model instead. So again, we can run that as a JUnit test. Oops. And voila. It will be it should match the getting a conference route, creating a conference, getting a conference, updating a conference, verifying that it's been updated, creating a session, and so on and so on. So let's see. The next one. Show you a another. This is graphene with. Well, it's actually just graphene with the reporting extension enabled. So in this case, we're gonna look for a conference. We're gonna insert some data, and hopefully that's gonna display an error for us. And this is using the page objects and the page component. It's not too much, but we can look into it. Just the main page has a couple of page components, which are the links, and the link has multiple sub elements. We can get the links that are on there, and then we can get a let's see, where is the component? The conference, which has a form in it. And the different CSSs and so on that needs to get the hold of the input component, which is basically just the wrapper around the input form, in this case, where you can send some keys or set some values, and it will attempt to say, is it displayed or does it have a error message on it? That's if the CSS has error is on the object itself. And at that point, we can run this one again, just to run as JUnit. We can see deploy a whole bunch of stuff. There's new fancy stuff in the output here. We're doing a full integration test, so we're actually signing into Twitter, using the Twitter account to attempt to create the conference and so on, and it's failing. It's failing because it should have displayed an error, but it doesn't for whatever reason. So when you get that type of error on your TI server, it can be sometimes hard to track what's actually going on. So one thing that the Arquillian recorder extension does is to provide options for instance, recording the screenshots of the browser before and after a given test, or on failure and that kind of thing. So we have set it up to report on failures. You can see here it's exporting that the add conference test case on the should show error message. Well, we can actually show the report completely. Where's the report? There. If you open that in a system editor, there you go. There. That's the report that it generates. But since this one failed, we actually have the before picture. What did this look like before it failed? Okay, fine enough. And then what does it look like after it failed? Well, we can clearly see that there's not an error displayed on this thing, which is why the test case is failing. But now we at least have some kind of upfront visual representation of why it failed, well, not really why it failed, but how it failed, before having to rerun the test suite on the local machine or similar to figure out what's going wrong. And then I want to do a quick one with the latest member of the Arquillian family, which is Cube. That's the Docker integration for Arquillian. So it's one thing to have the server or the container like Wildfly locally installed on your machine, and that alone, if it's only the Docker file, only the Wildfly server you're interested in. But normally you will have external resources as well, like some kind of queuing system, some kind of database, other web services, other systems that you need to interact with. And Docker makes that extremely easy. If you can Dockerize your different installations, it's very easy to download that and get it up and running on your local machine without having to have everything installed locally. So as far as the configuration goes for Docker and Arquillian, You need to know where the Docker server is. In our case, it's going to be on my machine. We're going to have a wildfly image that is being used. That's using this Docker file. So let's see. We're building the image on the fly. So we're saying based on the official JBoss wildfly image, we can add a given user so we can communicate with the management API, and then we're going to start up the server as normal. And then on top of that, we're going to add a database to this. So to take an order of execution, so we need to start the database first. So we're defining it that's an auto start container. So Cube or Arquillian Cube will just start up that as soon as Arquillian starts. Then we're using a container that's called the wildfly_database, which maps to this Docker image that now has a link to the database. So that Docker image can see the other database. And beyond that, the cube will handle anything like the port remappings of the default port. It will figure out what's the IP address that we're actually going to use to do the deployment or when we do the testing. So as far as that's basically all the configuration you need to be able to get up and running with Docker. And then the test case is a simple one. We're just trying to get a user repository that communicates with the database, and the entity manager stores it somewhere. You can see we're still using the database name, which is the link name in the Docker configuration. And yeah, just basically just installing something. So from the IDE again, we can run this, run as test, run as unit test. You see here, Docker starting up. It's starting the database. It's starting the wildfly server. And as soon as it's happy, it should shut stuff down again. There we go. That's the first test. It's executed. And come on, shut down. There, the wildfly is gone and the database is gone. So you can start to chain up how many and how big you want that specific environment to be, from being just this web archive, which could be a bean archive for a small bean container, to a local server, to a remote server, to a complete environment that you want to pull up to basically be a complete system test if you wanted to. And that concludes more or less my demoing section here. Continuous enterprise development in Java is some of the examples that you saw here come from. It's a book that me and Andrew Rubinger wrote that tried to explain some of these concepts and how to use them. And as far as Arquillian goes, you find us on Google Plus under Arquillian, on Twitter under Arquillian_org. The main site is arquillian.org, and we're on GitHub, of course, with an Apache 2 license project. There's a bunch more of extensions to explore if you want to get into them, from different types of app servers to different interactions with other third-party systems or frameworks that try to integrate them into the Arquillian universe. As far as getting started, the Arquillian guides on arquillian.org are probably the best ones. Gives you through some of the basics and get you up and running fairly quickly. And with that, I think I'm good. I can stop the sharing and.
Okay, I think that it's been. Yeah, it's been a really nice presentation. So probably because it has not been a simple, Arquillian presentation with a hello wall or this such thing, but showing drawn an Arquillian recorder and an Arquillian cube or Arquillian wrap, which is an advanced usage of Arquillian, which really makes for the developers writing tests in an easy way. We've got some questions which has been writing in our ERC channel. The first one is how is the integration with OGI for testing OGI systems, mainly for the services.
What do you mean? How is it?
Yeah, it's like they said that which kind of integration it has Arquillian for testing OGI systems.
Right. So it's currently it has support for Equinox, Felix, JBoss OGI, and Carath, either embedded or remote modes on most of them, I believe. And basically fairly similar to what you would do with a Java E test. You deploy a OGI bundle and have control of the bundle lifecycle. You can install other bundles and inject to different services and so on, or at least look up the different services.
Okay. Then the next question is about, we said that we have seen an example of Arquillian persistence extension, which you have to create a YAML file to populate the data. And the question is about if there is some way provided by the Arquillian persistence extensions to generate this YAML file. I mean, so sometimes preparing the data set it's quite tedious, and maybe you already have a database with data, and what you want to do is export that data to in this case, a YAML file.
No, we don't currently, but the YAML file isn't the only format we support. It's CSV files, Excel spreadsheets, XML files, and so on. So it shouldn't be too complicated to simply have a select statement that outputs some comma-separated values and use that directly. But I know Bartosz has been considering and wondering how to integrate with something like liquid base, for instance, either for knowing the upgrade or the migration path between different databases, or also some kind of automated import of data.
Okay, then there is another question about people were pretty impressed with the Arquillian recorder example. You know that you can instead of having a JUnit execution, you have an HTML file with the steps that have been executed. And they asked if that, for example, you can use Arquillian run, but instead of capturing features, recording the execution. Yeah,
you can record. It has a bunch of different options. One of them is just doing the screenshots. You can have it take a screenshot on every browser integration. No, sorry, every browser action. If you wanted to, you can have it always do before and after, or only if it fails, or you can do a recording, a video recording of the whole screen during the whole thing. So some of the things that we're slowly working on in that area is to allow the recorder to actually publish that data up to some service of some sort, and where you then can see the tests being executed as they are executed, but not from the Jenkins server necessarily. But you can potentially see a test cast if you wanted to see what's going on the server and see the test fail or not in some remote console.
Yeah, and now I think that it's the last question is that it seems that we are writing a lot of code to test our code inside our container, but mm, we are not writing more in our tests than in our code for production, or for our business code.
Was that a question or was it a statement?
Yeah, that was the question. Yeah, the question was the statement. But
Well, that
yeah,
I mean,
I have. Oh, so go.
you know, I would say for your business logic, the from point of view, probably most of the business logic you can probably manage to do in a JUnit level, or at least should be able to. When it comes to the container bits, what you're probably more interested in are things like transaction management or security login and more the integration bits of it. So you would hope that your business logic works at that point, but you want to see that it actually those two modules work together, or what those two modules do actually is being rolled back when something else fails, or yeah, I mean those types of issues, as opposed to just verifying that you can. If you want to calculate two numbers, I don't think doing that in a container is necessarily the most efficient way of doing it. That's basically what it comes down to. I think general good rule is to not bind your business logic to framework code too much, so you can actually test it outside the container.
Yeah, people say that the power that Arquillian is really powerful in the integration test. Oh, I will add it also in functional test or security test and that kind of test. Yeah, it's an understatement in this case.
Right. Yeah.
Well, I think that there is no more question. So, well, say thank you so much to Aslak for this amazing session, or I would say the introduction, but it hasn't been an introduction to Arquillian, and which has been an advanced cases of Arquillian, which I think that it's been great. And then remember that in our next session we will have Ivan talking about JBoss Forge, which is an amazing tool for creating Java EE applications really, really fast. So thank you, and we'll see you in next session.